Hey guys, we are Group 21 and our topic is statistical analysis of the factors influencing sleep efficiency. Our table of content includes introduction, literature review, EDA, methods, result and discussion, limitation and future study, and conclusion. I'm Dan Changfaran and my group members consist of Chin Wei Xian, Chu Jiaqi, Chia Yihang, Wong Kian-ming, and Tang Zixiang, and the presentation will follow according to the list. Firstly is the introduction. Our background of study is that sleep is a fundamental component to maintain a healthy lifestyle as it occupies 1/3 of our lives and it is essential for our physical and mental recovery. Sleep quality is typically measured by factors such as sleep duration and sleep efficiency. Our problem statement is that poor sleep quality have become increasingly prevalent, leading to health consequences. Understanding these factors influencing sleep efficiency is crucial as it is strongly affected by lifestyle and demographic variables. And our objective is to identify how various lifestyle and demographic factors impact sleep efficiency through statistical analysis. Parties affected are healthcare provider, public health official, general public, and wellness industry. The benefit and significance of the study is that it provides scientific contribution like analysis of sleep patterns and factors, practical application like healthcare professionals, individual and policymakers, and industry impact in developing innovative solutions for sleep-related challenges. Next is the literature review. In our literature review, we have reviewed 12 different articles highlighting that sleep efficiency is a crucial indicator of sleep health with significant impacts across diverse populations like elite athletes, frontline workers, and students, with factors like demographic, technology use, and health risks. The statistical approach used in the reviews are self-reported questionnaires, multi-level regression, ANOVA, and the most frequent model is logistic regression. The variables of interest are sleep patterns, sleep stages, lifestyle factors, and demographics. The key finding is that regular sleep results in high efficiency and better academic performance, while low sleep efficiency causes cognitive decline and cardiovascular risk. Sleep inconsistency causes nightmare and reduced quality in high-stress scenario, and nomophobia and high screen time causes disrupted sleep patterns, while older adults and females have specific sleep vulnerabilities.
Now we'll proceed to the exploratory data analysis. First, let's look at the dataset description. The data is sourced from Kaggle and is provided by Melike Delikci. The objective of this research is to identify the key lifestyle factors that influence sleep efficiency. By using the structure function in R, we can list out all the variables in the dataset. We can note that there are 452 records and 15 features, also acknowledging the data types. Next, the summary function provides a statistical summary of the features in the dataset. From the result, we can find out the central tendency, which are the mean and median, and the distribution, which are the minimum, maximum, and percentiles for the numerical variables. Also, missing values are indicated if apparent. For categorical variables, the total length, class, and mode are shown instead. Now we will go through the data pre-processing part. First, we'll be handling the duplicates. Duplicates are the repetitive records shown in the dataset. They need to be addressed to ensure data accuracy and integrity. Using the duplicator function, we can list out all the duplicate records in the dataset. The result shows that there are no duplicates, meaning that each row is unique. Next will be missing values. They can be identified using the sum is not available function to list out all missing values, which reports a total of 65 missing values. The column sums is not available function is applied to find out missing values in each column. Result shows that awakenings, caffeine consumption, alcohol consumption, and exercise frequency have missing data and needs to be handled. The imputation methods are chosen according to the skewness level. Median imputation is chosen for data with skewness more than or less than 1 because it is less sensitive to extreme values, whereas mean imputation is more suitable for normally distributed data. After replacing the missing values, the mean was recalculated. The minimum changes in the mean indicates that the imputation methods to address the missing values are suitable, which helps in maintaining consistency in the overall distribution.
Outlier can distract the analysis and lead to misleading conclusions if not properly addressed. Outlier were identified in sleep duration, deep sleep percentage, and also the caffeine consumption using the subtract function to detect the numeric columns and the broad.stat function to extract the outlier values. For sleep duration, where value typically range from 6 to 9, outliers at 5 and 10 were replaced with the median value of 7.5 to maintain the distribution integrity. However, in deep sleep percentage, the outlier at 18 was kept at a minimum threshold of 25% for consistency. For caffeine consumption, the interquartile range method kept the extreme value of 200 at the upper limit, effectively handling the skew data. Variable like gender and smoking status need to be converted into the numeric value for regression analysis. In RLD is done by using the s.numeric s.factor function, which first convert the data to factors and then to numeric values. For example, gender may be coded as 1 for male and 2 for female. This conversion ensures the categorical variables are appropriately handled by the regression model. To understand the dataset, we use the bar chart to show the distribution of categorical data like smoking status, and then histogram display the range and frequency of numerical data like caffeine consumption to help identify the pattern or unusual value. The third one is word plots, which were used to detect the outliers in numerical data, such as the sleep duration, which has the outlier at 5 and 10 hours. This visualization helps to identify and manage unusual data points. Scatter plot helps to visualize the trends and correlation between the variables. The left figure shows a weak positive correlation between the exercise frequency and sleep efficiency, suggesting that more frequent the exercise likely improves the sleep efficiency, but it is not a strong predictor. The right figure reveals a weak negative correlation between the alcohol consumption and sleep efficiency, indicating that higher alcohol intake may reduce the sleep quality.
Hi, my name is Ihan. Right now, I'll be talking about the method used for our study. We have selected multiple regression analysis as the statistical tool for our study. By using this model, we will be able to measure the connection among the factors or the predictor of sleep efficiency to identify the elements that create the most impact on sleep quality. With this regression analysis, we will be able to understand what affects variability of sleep efficiency and how much. The Shapiro test was first done to check the normality of the data. According to these tests, the default of the null hypothesis is that the data is normally distributed. The result produced will show the W statistic and a p-value. The null hypothesis is rejected if the p-value is less than 0.05, meaning the data does not follow a normal distribution. Correlation test was then done to reveal the significance of the relationship of the factors with sleep efficiency, where the correlation coefficient ranges from -1 to 1, which -1 represents perfect negative correlation as one increases and the other decreases. 0 means no correlation with the dependent variable, and 1 means perfect positive correlation, where both independent variable and dependent variable increase together. After fitting the model, we first run variance inflation factor to check the multicollinearity for each predictor in the multiple regression model. This is to ensure that the predictor is not highly correlated with one another, as it would cause disruption to result. The thresholds of multicollinearity can be seen as around 1, which is normal, less than 5, which is acceptable or low multicollinearity, more than 5, which is moderate but need attention, and more than 10 is high multicollinearity. Lastly, the summary of model is used to analyze key results of the multiple regression model. For example, the p-value for t-test examines on whether each coefficient is significantly different from 0. The adjusted R-square value accounts for the complexity of the model, ensuring overfitting is avoided. The F-statistic assesses the overall significance of the model, and the p-value tests the statistical significance of the overall model.
Hi, I'm Kiming here. So I'll be talking about the result of our study on sleep efficiency, including a brief discussion of the key findings and implications. The Shapiro test revealed that none of the variables follow a normal distribution with all p-values below by 0.05. This highlights the complexity of sleep data, which is influenced by non-linear and multifaceted factors such as lifestyle and demographics. The correlation analysis show strong negative impacts of light sleep percentage and frequent awakening on sleep efficiency. Conversely, deep sleep percentage and exercise frequency positively influence efficiency. Lifestyle factors such as smoking and alcohol consumption were also found to be significant negative predictors. So the variance inflation factors analysis confirmed that were no multicollinearity issues among predictors with all Y values close to 1. This ensures that the predictor contribute independently to the model's results. The regression model performs strongly with an adjusted R-square of 0.799. This means the model explains 80% of the variability in sleep efficiency. The most significant predictors were REM sleep, deep sleep, smoking, alcohol consumption, and awakening. From this finding, it is clear that deep sleep and REM sleep plays a crucial role in improving sleep efficiency, while smoking, alcohol use, and frequent awakening significantly reduce it. While the model is robust, residual scatter suggests unmeasured factors such as stress or environmental influences may also impact sleep efficiency. Future research should focus on incorporating these variables to refine the model further and enhance its predictive power.
Hello everyone, my name is Dang Zixiang. I'm going to explain the limitation and further study. So first limitation is the dataset. Our study relied on 452 record A might not represent diverse population. Next, we encountered the issue with the self-report data might prone to inaccuracy due to intention misreporting. And also the exclude factor like stress, diet, mental health will also impact the sleep efficiency but did not in that dataset. Like the environment condition also excluded, this method also will affect the sleep quality. Lastly, our superior weak test indicate that dataset was normally distributed. This might affect the accuracy. So for further study to improve the reliability, we should use larger dataset. Also for self-report data, we also can use the objective tool like wearable device to provide more accurate result. Also, you can include the stress, diet, this pattern, and also monitor the environment condition with sensor. So for the further study, we also can consider using non-parametric statistic method to address this issue. So lastly, to conclude that our study aimed to identify and quantify how lifestyle and demographic factors influence the sleep efficiency. We're using the multi-regression analysis to explore this relationship. So this sleep percentage was the most significant positive factor, meaning it greatly improved the sleep efficiency. On the other hand, the light sleep percentage and frequent awakening was the most negative factor, reducing the sleep efficiency. In terms of the lifestyle, smoking and alcohol consumption were associated with the decreased sleep efficiency, while exercise frequency has a slightly positive effect. So importantly, our model explained about 80% of the variability in sleep efficiency. That's all for our group presentation. Thank you very much.